Let's move on. Here are the first 4 terms of the sequence. Find the 5th term of the sequence. A lot of students, for some weird reason, struggle with this. If you were me in Sec 1, Sec 2, I've shown you quite a few of such types of questions. When you have number pattern questions in general and they give you fractions, very often you isolate your numerator and your denominators. They are 2 different patterns. Okay? So you can draw a line across and you will pretend that there are 2 separate set of numbers, 2 separate patterns. Yeah, Joven, you can go. Remember to watch the recording. Enjoy English. Lol. Okay, now, so what do you see is the pattern for the numerator? Very straightforward. What do you see is the pattern for the denominator? Also very straightforward. Correct. So isolate the patterns. Anyway, your 5th term, please don't use general formula. Please just go and count on. Because students find 5th sequence, they go and use the general formula, which obviously is not wrong, but Tn is the n term of the sequence. Find an expression in terms of n for Tn. So I'm just going to write the numerator and separator, numerator and denominator separately. So for your numerator, so Tn for numerator, then this is where you must remember the general patterns. What's the general pattern? This is called what? This is called your constant difference pattern. We call it constant difference because while normally it is plus, it can be minus, it doesn't matter. Okay? So your constant difference pattern, the general form, you must remember. And when we were going through your topical revision, I already showed you all the formula, right? It's in your N5 to N7 set of notes, I think, if I'm not mistaken. Okay, if you don't know which set I'm referring to, it is this set. There are 10 million things there meant for you to read. Oh, really got 10 million things. Anyway, imagine you scroll to the end and realize it's the wrong set. Absolutely awesome. Okay, your general formula for your number patterns are here. Both your arithmetic and geometric sequence and your triangular sequence and your square numbers, cube numbers, quadratic sequences, so on and so forth. They are all here. I already, myself or Miss Venus already go through, so by right you should already know. So this is the general formula for this pattern. It's your constant difference pattern. Okay. So if you look at the formula, Tn is equal to T1 plus n times n minus 1 times constant difference. Which set? This is your 10b6, n1 to n4. Okay, I spend a lot of effort to type out the notes for you all to go and revise, not for you all to conveniently skip because I skip everything. Please, half the set are notes that you are expected to go and read and remember. You have to read and remember, then you can apply. So your general formula is this, T1 plus constant difference times n minus 1. I already explained to you all why it's always n minus 1 because there's the number of jumps or the number of gaps or the number of intervals. Okay, so your Tn for your numerator, in this case, your constant difference is 4. So 4 times n minus 1 plus your first term is 1. Then, okay, sorry, I said I will do them separately. So Tn for numerator is this. Then your Tn for your denominator is equal to, your constant difference now is 2. So 2 times n minus 1, but your first term is 2 also. You must simplify, so we shall go ahead and simplify. 4n minus 4 plus 1 is 4n minus 3. Then 2 times n minus 1 is 2n minus 2 plus 2 is 2n. Correct? Therefore, your overall Tn is just equal to 4n minus 3, which is your numerator, over 2n, which is your denominator. That's how you express the answer. And you will notice that normally, the n term of the sequence is a 2-mark question. In this case, it is 3 marks because they need you, because there's a numerator and there's a denominator. That's why it is a 3-mark question instead of just a 2-mark question. So you needed to find the numerator and the denominator separately, and then synthesize it to get the answer. So I guess 1 mark for 4n minus 3, 1 mark for 2n, 1 mark for correct answer. Okay. Let's move on. They then go on to tell you that the difference d between 2 consecutive terms is Tn plus 1 minus Tn, which, if you think about it, makes perfect sense. If you think about it, it makes perfect sense. This is your n plus 1 term minus your n term 1. I could also write it as what? Tn minus 1. My n term minus my n minus 1 term, and so on. Okay? Show that this difference is always equal to this. So what do we have? We know what is Tn, right? So Tn, as we found just now, is 4n minus 3 over 2n. So what is Tn plus 1? Tn plus 1 by substitution. So you all must know this. So a lot of you get confused because you don't understand what Tn means. You know that you need to find this, you memorize this to find Tn, but you don't understand the logic of what Tn means. Tn means the nth term. Tn plus 1 means the n plus 1 term. So I can have, for example, what is T10? T10 means the 10th term, means my n is 10. This is called T10. So what is T, for example, 999? It will be this. So basically, you substitute the n with whatever value term you are finding. Correct? So what exactly is Tn plus 1? Tn plus 1 means you just start in n plus 1. So it's just 4 bracket n plus 1 minus 3 over 2 bracket n plus 1. So some of you get confused. You know how to substitute it, especially by numbers, but then when I tell you n plus 1 term, you're like, what is n plus 1 term? That is just what it means. Instead of substituting n, you substitute n plus 1. Okay? And that gives us now you need to find the difference d. So d is equal to, sorry, I need to expand tn plus 1 first, because that will be easier. So this will give you 4n plus 4 minus 3 will give me 4n plus 1. And this will give me 2n plus 2. And therefore your difference will be tn plus 1, which is 4n plus 1 over 2n plus 2 minus your original tn, which is 4n minus 3 over 2n. From here, nothing better to do. Basically, what is this question telling you? This question is just showing you. So this entire number pattern question is just showing you what? It's just showing you, it's just asking you to simplify the algebraic fraction. So how to simplify algebraic fraction? You make denominators the same. And you look at what they gave you. Okay, take note of that. So it's in factorized form. It is not in expanded form. So that is something for you to take note of. Okay, but regardless, we multiply by the common denominator first. Okay, it's in the factorized form means I only want to expand the numerator, not the denominator, but it's fine. Since I already expanded. So you multiply this by 2n, and then you multiply this by 2n, you multiply this by 2n plus 2. Because I expanded it, later you need to know how to simplify it. It will be simplifiable because I expanded it. I should have just left it in the factorized form, but it's fine. Okay, so this will give you 8n squared plus 2n minus, and this is where you must be very careful. You need to put a bracket. You need to put a bracket because it's a minus. A lot of you don't like to put the minus bracket with the minus, and then you forget to change your sign in the middle. Okay, this one is your rainbow expansion. So 4n times 2n, 4n times 2, negative 3 times 2n, negative 3 times 2. And so that will give you 8n squared plus 8n minus 6n minus 6. Okay, please make sure you have your bracket because of the minus sign, because that changes the sign inside. And then your denominator is just 2n times 2n plus 2. You do not expand the denominator here because if you recognize in the original D, they tell you that the denominator should be factorized, which is what I should have done just now. I should not have expanded it, but it's fine. So from here, change the sign, you will get 8n squared plus 2n minus 8n squared plus 6n minus plus 8n minus 6n supposed to be positive 2n, but because of the minus sign, it becomes negative 2n. Okay, and then minus 6 will give me plus 6. Then your denominator. Now, this is where you need to be very careful. So 2n plus 2 can factorize out the 2. So this will give you 4n plus 1, which is how you get n plus 1 in the original equation in the first place. And then from here, you simplify, the an squared will cancel out. You are just left with 6 because this will also cancel out with this. So you are left with 6 over 4n times n plus 1, and you should realize that 4 and 6 can obviously cancel. Shown. Okay. So all they are asking you to do is to simplify the algebraic fraction. That's all. All right. Question D is another question that students struggle with, but thankfully it's only 1 mark. Now we go back to this. So this one not so standard. Normally, this kind of question they'll tell you, oh, show that it's always a multiple of 3, always divisible by 3, so on and so forth. And in this case, you can show that it's always divisible by 3 because the 3 is a factor and stuff. But this one a lot less standard. Explain why the difference between the 2 consecutive terms is always less than 1. How do we show that it is always less than 1? Obviously, you know that the answer cannot be negative. It's a fraction. It cannot be negative. You must understand that it cannot be negative first before you proceed. Why cannot be negative? 2n times n plus 1 will always be positive because n is always more than or equal to 1. So the first thing you must understand here is that n is always more than or equal to 1, and n is an integer. N is a positive integer because n refers to your term number. Your term number always start, you have term 1, term 2, term 3. You don't have such thing as term 0. You don't have such thing as term negative 1. Therefore, your n is always more than or equal to 1, and it's always, in other words, a positive integer. And so based on this, because this is a plus, the term can the difference can never be negative. The difference can never be negative. So that's the first thing we will establish. The difference cannot be negative. But why is the difference always less than 1? What sort of equation will give you a difference that is less than 1? That means it is always a proper fraction. It will always be a proper fraction. Because if it's an improper fraction, then it's more than 1. So you are trying to explain why it will always be a proper fraction. So now we look at this. Since n is always more than or equal to 1, 2n times n plus 1, which is your denominator, will always be more than or equal to 4. When n is 1, this value will be equal to 4. When n is 2, this value will be greater than 4 already. Okay, you understand the logic here? So once you get this, you know that 2n times n plus 1 is always more than or equal to 4. Then since the numerator is 3, since d equals to 3 over 2n times n plus 1, the denominator more than or equal to 4 means the difference is always a proper fraction and therefore less than 1. That's all. So the condition you must establish to tell me that since n is more than or equal to 1, your denominator is more than or equal to 4, and 3 out of 4 or anything larger is always a proper fraction. Or maybe you want to be slightly clearer, you explain one extra thing. Means the numerator, oops. So your denominator is always more than your numerator. Okay. So a few things here. So you show me that the denominator, which is 2n times n plus 1, is always more than equal to 4 when n is more than or equal to 1, which that it must be the condition. And therefore, your denominator always greater or equal to 4 means that your denominator will always be larger than the numerator. Okay, your denominator will always be larger than your numerator, and that means mathematically that your d will always be a proper fraction, and since it is always a proper fraction, it must be less than 1. Because all proper fractions are obviously less than 1. Okay, I hope you all get the logic here. Students always struggle with explaining questions. Thankfully, it's a warm-up question, so even if you don't know how to explain it, it doesn't matter. Okay, if you want to be a bit more specific even, you will realize that your d, in this case, must be greater or equal to 3 out of 4, which is greater or equal to... it cannot be equal to 1. It's strictly always less than 1. It cannot be equal to 1. It will always be greater than 3 out of 4. No, sorry, it's the other way around. D will always be less than or equal to 3 out of 4. The maximum value that D can be is 3 out of 4. Okay. So for 1 mark, I mean, even if you don't know how to, but this is the logic behind it. It's not a very common question type. Okay, so it requires some thinking. But thankfully, the rest of the question is quite straightforward. So every year they will test number patterns, but you notice that don't just test number pattern. Usually when they test number pattern, they will test it with something else. Like in this case, algebraic fractions. All right. Can? No problem. No problem.